What did I call this? What? Yeah. I'm mistyping all of the things. Okay. So this thing is, I'll show you in a sec. This is going to be rough with all the letters. What is this? Okay, so I'm going to run it first, and then we'll talk about what it is. So this thing is a bot frameworky, conversation-y menu tree thing that I threw together in Haskell, and it'll be cool. Anyway, so this is just running off the command line right now. So it says, hey, this is DevHouse, why are you here? And it gives you two prompted options, for code or for me. So I'll go with code. And then it responds, it says, that sounds kind of lame, also what's your name? And I say, Rufus. It says, it's mean to me. And then it says, do you know Haskell? And I say, nope. And it says, oh, so you want to learn it? And I say, nope. And it says, that doesn't sound right. Let's try that again. And I say no again, and it's like, no. So then I say, yeah, it's like, okay. And it says, yeah, well, I think I'm about done here. Thanks for everything. I don't like you a lot. And then it gave me a 1, which I'll come up with later. So that's basically it. So the code, though, is hopefully interesting, and if it's not, then, the next presentation will be. So I can make this a bigger. So, Haskell. So the way that this looks, first I'm going to talk about how it's written, and then later I'll talk about how it's actually written. So this is the top of my tree here. It is, and if you don't know Haskell, just kind of like fuzz your eyes enough to get through that. Because, this is not a Haskell introduction. So DevHouse here is the top of my thing. It's a bot that returns an int, which is this, incidentally, this 1 over here. So like throughout the whole tree, at the end of it, there's an integer. Mostly that's in there just in case I wanted that. So it starts out, it says, say this thing, and then it asks me for these, to pick one of these options, and it puts that over here into Y. And then it goes through and it says, okay, if he said code, then say this and return 0, which goes over into this first here. Otherwise, if he said Christopher, then say that and first is instead of 1 instead of the 0. Then say this. This is a free form thing, so I can say whatever I want there. If I were to, actually I can, okay. So if I quickly run this again, and if I get to here and I say, screw you, it just says, sorry, I didn't get that. It asks me again, because that's not one of my answers I wanted. So that's fine then. So I've got my cases here, blah, blah, blah. I've got my freeform though, where it doesn't do that. It just puts my answer into this name thing. It says, I don't care that your name is, and then this thing. It asks me my question. This time, though, it takes my answer, and if I say yes, then it runs the yes Haskell tree, and if I say no, it runs a no Haskell tree, because like I could put it here, but that would be kind of big and ugly, so I broke those out. But I put the result of either of those into the second variable here, and it says I've just about done here, thanks for everything. The total is the first plus the second, and then if the total's a 1, I say I don't like you a lot. If the total's a 2, I say you're alright but kind of lame. And if the total's a 3, I say you're the best. And if the total isn't 1, 2, or 3, I made a clerical error, but that's okay. And so it just says weird, and then it returns the total, which was the one that we saw earlier. Yes, Haskell. Again, I say what do you like about it, types or other stuff. I say types, I say me2 and I return 2, because that's a very good answer. And if I say other stuff, I'm nonplussed, and I return 1. And then in no Haskell here, if I say yeah, then I say yeah, and then I return 1. If I say no, I just call no Haskell again, and it goes around in an infinite loop until you pick the right answer. That's it, basically. That's my language for building bots. So, I could have written it pretty simply, right? It's like a command line app that asks you questions and receives responses. That's not groundbreaking. But what is kind of neat is I can turn this on like that, and then I can run it, and this time it's now listening on a socket. So now, LX term, nope, that didn't work. What have I done?
Let's just have one open behind you.
Yeah, I guess. Okay, so I'll just quit that for a sec. So if I run netcat localhost 3456. So now I'm communicating it over TCP instead of on my command line. So it's the same thing. John, yup, types. Great! But now it's a TCP thing. And if I run this one here, and then I run another one, and so I can also run netcat localhost 3456 over here, and now it can be like code, and then it's like, oh cool, but this person's here for Christopher, so that's cool. And this guy's name is Steven, and then this person over here's name is Ricky. This person knows Haskell, this person doesn't know Haskell, this person says the wrong thing 4 times in a row, this says yeah, this person very exciting demo. Anyway, so now we're done, and those were 2 like independent conversations that I had, but I didn't actually have to like rewrite my bot. My bot was magic. That's the technical term for it. So if was I not just editing the code over here?
I don't know which one.
Yeah. This is going great. Okay. So my bot was identical in either case, and what happened down here was instead of calling local main, where I run local driver DevHouse, instead I run socket main, where I print out the port I'm about to listen on, and then run socket driver DevHouse. So obviously all the magic's in there. So we'll go to bot driver local, but that's it. Local driver doesn't do anything. I mean, like, it does something. What it does is it takes in this bot here, it calls run bot, with this pogo function over here, and then it takes this thing and the bot, and then it just prints out the result at the end, which is that 1 that you saw. And my pogo function doesn't really do a lot either. My pogo function just takes in a thing of that is a request with a rec that has sentences and options. It prints out every sentence. It puts the prompt. Where's the prompt come from? Oh, this is the prompt down here, where I just take all my options, I join them by strings, and I put the little this thing on the end, and then I flush so that my prompt gets spit out even though there's no new line. Then I grab a new line, and then I pass whatever that was to this cont variable I got over here, and that's it. So there's not really a lot of magic there either. And if I run the socket one, the socket one, again, there's like a little bit more code, but still not really a lot. I'm just saying serve this thing with this port on the session bot, and the session bot's over here. And again, it's just, I've got this run bot function again, and this time my socket pogo, which lives down here. And in this case, again, I take the same input. This time I run like send many on my socket for my outbound sentences. Again, I join the things with a string and put the thing on the end, and I send that over the socket. I receive from the socket instead of get string, and then if I didn't receive anything, it's an error. Otherwise, I run continue, which kind of goes around the loop again. So the magic doesn't live there either. Now that I've showed you all the places the magic doesn't live, let's talk about the magic. So, the way that this is written is with coroutines, which are fancy, and I'm not really going to talk about it a lot. But basically, normal control flow that most people are familiar with is like there's a function, and at some point that function calls another function, and then that function does something, and then at some point it returns a value, which returns to the caller, and then like that's a thing. Coroutines can take a couple different forms, but the one I'm using basically is rather than having a function you call that returns a value, instead you have a function you call that can return in more than one place. And so you can have your functions kind of step through one another. And so your function, can run to here, and then it calls this function, which does something, and then when it gets to here, it returns with, say, a list of options that you want to send to the user, which gets sent back over to the calling function, which then does some stuff with them, and then later kind of jumps back into the function where it left off, which then continues and then returns and comes back, and you can kind of go back and forth. And that is how my tree works, basically. Is if I pull up my cotest again, the reason that I can build this kind of agnostic to whether or not I'm at a terminal or I'm parallel and multiplexed across sockets or I'm an HTTP receiver sender or whatever the hell, is because this is the function being called and it runs through here, and then this ask is kind of concealing a return or yield in the terms of the art. So rather than returning though, which would just end this whole tree in a normal function, instead it takes this data, packages it up and sends it to the sender, which can then send it out to the user, wait on whatever the hell they were doing, wait on a response to come back from the terminal or the socket or whatever. And then when they're done with that, they can call the continuation, which means, okay, here's the response of that data. You may pick up where you left off, and it just kind of keeps moving. Which is, in a situation like this that's very asynchronous, but wants to kind of be written synchronously, it ends up being kind of natural feeling, because I don't have to have a database where I like store the answers that have come by so far so that I can remember where in the conversation I ended up. I just kind of put this response in a variable, and then I can use it later. Because it's all in my little function scope, it never left. I just kind of paused for a bit and then picked up where I left off. And so I can have this whole sort of blocking and resuming thing, and it doesn't look like it necessarily. Like I specifically built it this way, but it looks relatively like a straightforward tree. And in theory, I could even build a driver that just like fed it pre-canned answers and wasn't asynchronous at all, but that's no fun. So I'm using the coroutine monad transformer, which we'll gloss over completely. So I didn't even have to write the coroutines. That's just a library that came for my thing. Basically, the way that I'm using it is I've got this request object, which has like the list of things to send and a list of options to prompt them with. And this is what my coroutine actually does. So my say method here. Oh, and the other thing is I've got an accumulating state monad as well, and which is how I keep track of the things I've said but haven't said yet. That could be done in a different way. I just didn't. So when I say something, I give the words here, and basically what it does is it takes this structure that I have in my state, and it just adds the things I just said to the things to say. So if I say 3 times in a row, it just accumulates the things to be said, and it gets there later. This is not the most efficient thing I could have done, but the list is like 3 big, so that's it. My freeform here, what it does is it gets the things to say, it clears my state, and then it does a request with this request of, I build this request of like the things I wanted to send and my prompt, and I request that, which wraps the part that goes into the coroutine stuff, And ask is very, very similar. Actually, I probably could have wrapped that. I wrote this like 10 minutes before you guys all got here. So this could use some refactoring. But so this, oh no, I can't. Anyway, so this goes through and gets the responses, and then it basically just says if the response is in the list, then clear it and return it. Otherwise, say sorry, I didn't get that, and ask with the same options again. And then my runbot function is the thing that actually is the thing that kind of like turns the final crank. And it says, okay, run my state T with my pogo stick, which is a function provided by the library with the pogo I was given, and my bot, and it starts off with an empty list of things to say, and then at the end it says the things that were said, and then we're done. And then the pogo is actually the part that handles the like, hey, you have been yielded to, what do you want to do with that? Here's the thing to call when you want to resume. And that's the thing that I showed you earlier that differs slightly between the two. I think that's basically it. And then other than that, Haskell is magic, and it makes me happy. Yeah. I'm gonna go with that for now. Does anyone have any questions, or did I miss anything totally completely? I mean, besides the fact that I was like shooting high with a lot of the explanations. Questions?
What if
Yeah.
you had this running on a server somewhere
Yeah.
and you wanted to be able to restart it while the users are talking to it?
What an interesting well, I suppose in theory, if Stephen wanted to, he could write a thing that serializes coroutines, but I don't know anything about that. Yeah, basically. One of the flaws with this particular method is that because everything is stored in state, just in my process here, like all these variables and stuff are just, I don't actually put them anywhere persistent, they just live for as long as you want. If you stop the process and restart it, all of the existing conversations kind of like just fall to the floor. Not super ideal, but it's kind of cool anyway. So there are things you could do to mitigate that if for planned failures. For unplanned failures, you're just kind of screwed. Because this is kind of a proof of concept and not like a real product. For planned failures, you could do like swap in round robin-y stuff where you're like, yeah, I'll put these people over here, but I'm not going to write anyone new over there. And then like when their conversation's done, I'll shut it down. And that takes also a lot of stuff that I haven't written here. Stephen happens to have made something not in Haskell. It's very similar to this. Kind of like taking it another step forward, using a feature of PyPy?
Yeah.
That actually stores the coroutines rather than just holding them in process, which means that if you shut the server down and back up again and then someone comes back to you, you can just like de-pickle the coroutine and then run it, which is super cool, but I didn't do that. He did. And if we're lucky, maybe he'll talk about it, but probably not today. Probably not today. Maybe in January. Because that was also super cool. And similar, but different than Python. To fix that hole. Any other questions?
Are there any tools to make understanding the code better or faster? Like Visual Studio, find all references, or skip to definition, or thing like that?
Are there any Haskell IDEs?
Yeah, there are
Probably. I've never looked, but probably.
Yeah, there are a couple. Usually, the sorts of people who want to write code in Haskell, similar to like Ruby and other languages like this, are the sorts of people who don't want an IDE. So they're not popular, which means that their feature sets are less complete.
Just because they're not as
the Java IDEs are really good because the sorts of people who want to write in Java are the sorts of people who want IDEs, so they spend a lot of time writing IDEs.
I would say really complete. Good is a strong word.
Yeah, well, anyway, yeah. So there's like a lot of features in a Java IDE, and like most of the Haskell IDEs are more middle of the road in terms of the features they have. So there's like Yi, and there's Alexa, and there's also FB Complete has an online webby IDE thing, which is probably the best one if you're into that kind of thing. But yeah.
So they're probably out there, but I've never looked.
From my understanding, in principle, it looks like the language philosophy is so that you don't need tools. Let's say if you write big programs, it looks like you don't need these kind of tools because of the nature of the language,
I mean, like, you can write bad code in any language that is hard to navigate. Some languages are a little more bulky than others.
I think Haskell is one of the languages that encourages you to write big programs in small pieces.
Yes.
So that whatever piece you're looking at is small, and most of the magic it needs is often something that you don't care about when you're writing it.
Yeah, well, and like this method here, which is like fewer than 17 lines. What is that?
That's long
Oh,
for
sorry.
a Haskell function.
Yeah, that is like the longest Haskell function I've ever written in my life. Because the nature of the language is very composable, and so it like Dave said, it encourages, just kind of naturally, it feels right to just build a lot of small parts and then string them together in small parts and then string those together.
Do you consider pattern match alternatives different functions for the purpose of largest function you've ever written?
Yes, I do. Yeah, because they are kind of like distinct bodies.
Yeah.
And then the other thing is, I mean, like other languages have this too, but Haskell's import system is also pretty robust, which also encourages you to like break things out into submodules and hide things from these modules that you don't want to see over there. And so it also kind of keeps the interfaces relatively clean. It keeps the files relatively small. You can build files, for example, that are like that basically just like throw together different collections of other things. But it's also not super common to do that. Usually your methods that you want are like one jump away. And I mean, you don't have to write it like this, but I also almost always do qualified imports. So if I'm down here somewhere and I want to know where lookup env is, well, actually, where am I using that? Am I even using that? I'm not. But anyway, I can just find it without having necessarily to have a thing that goes through a whole tree. I can just look for this and be like, oh, it's bot driver socket, and because Haskell has strong opinions, that can be found in bot driver socket, and that's where it is. So, I mean, like, I don't know. I don't use IDs in a lot of languages, but in Haskell, I've never really felt the need to have one, personally.
You are also using a lot of the built-in features of Vim.
I use Vim more than a lot of people. Yeah.
Vim is effectively your IDE because it does most of everything that you need. You don't really want much more.
Basically, I mean, like there are some people who use more features like built into Vim than I do, but the features that like I use a lot of Vim features to make it easier. I mean, and most of them are VI features. But yeah.
Well, I just saw you did a code or a key press and a jump from the bottom of the file to the top. So obviously that was
one.
potentially
Yeah.
a search function of some sort.
Yep.
Yeah.
Yeah, that one is search for next occurrence of token I'm sitting on.
Yeah.
And other such simple things. But yeah.
Commonly referred to as star, obviously.
Yeah,
Because
actually-
what else would it possibly be?
Well, actually, yeah. I mean, in is it in NVI? I think it's at, because that's anyway. I dabbled. Yeah. It wasn't there at the time. Any other questions? Lovely.